Hello everybody. In this video we are going to be looking at the solution to the honors electromagnetic induction due right now number 3. Fooled you this time. All right, let's take a look at the problem. We have a 12.0 meter long steel beam is accidentally dropped by a construction crane. Oops. The horizontal component of the Earth's magnetic field over the beam is 18.0 microteslas. If the induced EMF in the beam just before it impacts the ground is 2.87 millivolts, from what height was the beam dropped? All right, let's take a look and see what we are given here. We are given the length of the beam, which is 12.0 meters. I am given the magnitude of the Earth's magnetic field, which is 18.0 microteslas. When I convert that to teslas, I will have 18.0 times 10 to the minus 6 teslas. The induced EMF in the beam just before it hits the ground is 2.87 millivolts, which when converted to volts will give me 2.87 times 10 to the minus 3rd volts. And we are being asked to find out the height that the beam was dropped from. Well, if we're asking for the height that the beam was dropped from, we know at some point we're going to need to use, you guessed it, a kinematic equation. That's why I love this problem, because it brings back our kinematic equations. They never go away as much as you want them to. Before we can find the height that it's dropped from, I'm going to need to know how fast the beam is traveling right before it hit the ground. And for that, I can use one of my electromagnetic induction equations. If I'm given the length of the beam, the strength of the magnetic field, and the induced EMF, and I want to find the velocity, I'm going to want to use epsilon is equal to B times L times V. Solving that equation for velocity will give me epsilon divided by B times L. I plug in my known values to that equation, and I'm going to get a velocity of 13.3 meters per second. So the beam is traveling at 13.3 meters per second just before it hits the ground. Now I know that if the beam is dropped, we're told that the beam is dropped. If the beam is dropped, I know that my initial velocity V naught is equal to 0. And I know, of course, my gravitational acceleration is going to be 9.8 meters per second squared. So I have my value for G is 9.80 meters per second squared. I am trying to solve for my final velocity. And I want to, no, I do have my final velocity. Sorry, I'm not solving for that. I am solving for my height. So I'm solving for y. So if I have those 4 variables and I look back at my kinematic equations, I know that I'm going to want to use velocity as a function of displacement. And we are in the y direction, so we're going to use the one for free fall, essentially, is what's happening with the beam. The beam is in free fall. So I'm going to have Vy squared is equal to V naught y squared minus 2 times G times y. Solving that equation for y, I am going to have Vy squared minus V naught y squared divided by negative 2G. And when I get to plugging my values into that equation, remember my velocity before it hits the ground should be in the negative direction. I am going to have a height of 9.0 meters.